Let's now take a look at the slope, also called the gradient. And well, there's different ways we can find the slope. Probably the first way we looked at was vertical rise over horizontal run. So let's just draw a quick picture. Here's the line L. So we've got 2 points there, 5, 5, 2, 1. We'd probably end up using our formula rather than vertical rise on horizontal run. So that was the next way we saw of finding the slope. y2 minus y1 over x2 minus x1. So our line L there has a slope of 4/3. Here's another line, capital L, the blue one I've drawn in there. But all I know about that line is it makes an angle of 120 degrees with the positive x-axis. And that brings us to our third way of finding the slope. The slope will also be the tan of theta, where theta is that angle of inclination, but it has to be to the positive side of the x-axis. So I could work out the slope of L, tan of 120, one of our exact values, minus root 3. I could also now go and find the angle that the red line makes with the axis, because I could say, well, tan alpha must be 4/3. So alpha is around 53 degrees. Two lines will be parallel if they have the same slope. And no, I haven't spelt if wrong. That means if and only if. That basically means you can read this backwards. So whilst I've said two lines are parallel if they have the same slope, we can also say two lines have the same slope if they are parallel. So basically slope 1 would equal slope 2. Two lines are perpendicular if their slopes are the negative inverse of each other. In other words, their slopes multiply together to give -1. And that one also reads backwards. So if the fact you know that they multiply together to give -1, you can conclude that the lines are perpendicular. So we've got 4 points. Problem is, in our fourth point, we don't know the x value. We want to find it. So first of all, let's find it. And if the fact we know is that AB is parallel to CD. So that means the slopes are the same. Well, slope of AB is 2. Slope of CD is 2 on A minus 3. But we know that if they're parallel, then the slopes are the same. So 2 will equal 2 on A minus 3. So A on A minus 3 must be 1. A is 4. What about if the lines were perpendicular? Well, if they're perpendicular, then those slopes multiply together to give -1. So now 2 times 2 on A minus 3 is -1. Solving that little problem, we get A is -1. We've been given 3 points and we're told they're the vertices of a parallelogram. We want to find D, the fourth vertex of the parallelogram. Draw yourself a diagram. It's going to make life a lot easier. So let's plot in the 3 points we know. We have to find the fourth point to make a parallelogram. Now the naming of the parallelogram is important. Because they've named it A, B, C, D, D must be in this position. It's the only place it could be. So all right, what do we know? We know to go from B to A, we've gone 3 across and 5 down. In other words, the slope is -5 on 3. But that means if I go from C to D, we must also go 3 across and 5 down. So rather than using a whole heap of formulas, I'll just use that idea. So I'm at -3 minus 5. If I go 3 across and 5 down, then I'm at the point 0, -10. So there's our coordinates for D. If you want to prove 3 points lie on the same line, so they're collinear, steps. Well, way we do it, pick 2 of the points. Let's say they're A and B. And we'll find the slope between those 2 points. Pick another pair. So A and C. Find that slope. If those slopes are equal, then the points must be collinear. Why? Well, slopes are equal, so they're parallel. But AB parallel to AC, there's only one way that can happen, and they both have the point A. That's if in fact we're talking about the same line. So hence they're collinear. 7B.